So yesterday I think we were looking at data types. So any questions up till now? Yeah. No. Okay. So then let's proceed. So yesterday we looked at the data types. So we started looking at the data types, and we have got two categories of data types. We say we have primitive data types and the reference data types. Right? Primitive types built in from the language itself. Right? Those were similar to the types we find in C language. And we find byte, short, int, long, float, double, char data type, and the boolean type. Okay. Okay. Fine. And then we saw the sizes for each of them. Okay. We are looking at how to specify the literals for each of the types. Right? How do we write the literals for numeric types? Literals for numeric types. You can specify a literal means a constant. Okay. So numeric constants can be specified as binary, octal, decimal, or hexadecimal. Right? In any form you can specify the value. Okay. Um, and then so I think we have yesterday we looked at which literals. I think one was, I think we started with the char type. Did we look at the char type? No. Do you know the floating point types now? The type float and double. Okay. And for float, if you have some decimal or something, you have to have a suffix of f, right, to indicate it's a float type. So then it becomes a 32-bit single precision floating point value. Double is your double precision floating point value. Okay. Also, we saw, I think, about uh, that in case of float and double, right, there is representation for infinity. I'll just review that again for you. What exactly is the case here? One second. See, float and double, how they work is something like this, right? Float is 32-bit. So a float which is 32-bit is actually divided into, you can think it's divided into three parts. Okay, this is something which is also true for double. And there are three things in it. The most significant bit here is the sign bit. This is for the sign. Okay, and then we have some initial bits. Okay, there are, I think it's 8 or 9 bits, which are for the exponent part. and then the rest of the things. See, okay, this float and double, and what is the kind of specification they are following? They are following what is known as IEEE 754. So if you want to have more details, yes, you can search for what is IEEE 754, and you will know how exactly float and double have been organized. Okay, so in that particular specification, they call it as they don't use the term multi-sat, they call it as significant. So there is one bit for sign, then we have some bits for the exponent part, and then the rest of the bits are for the significant. Exponent for float is 8 bits. So 1 bit and 8 bit, 9 bits, and rest of the bits, that is 21 bits, are for the significant. Oh, sorry. 23 bits. Yeah, sorry. Okay. Fine. So that's how the things are divided. Now, when it is when all the exponent bits are set to 1, okay, if all the exponent bits are set to 1, whether it's float or a double, right, then it is not representing a finite value. Okay, it's not representing a finite value. If all exponent bits are 1 and all the significant bits are 0, okay, everything here is a 0, okay, then it is an infinity. Okay, exponent bit 1, significant bits all of them zeros, it's an infinity. The sign bit will decide. If it is 0, sign bit is 0, it's a positive infinity. If sign bit is 1, it's a negative infinity. Then in the sign bit, a 1 indicates negative. Okay, fine. Now, what about if all exponent bits are 1s and we don't have all zeros here but some other kind of a combination? So anything which is having all exponent bit 1s, okay, and if the significant bits, if they are all not zeros, then all such combinations are known as NN. They are considered as not a number. Okay, fine. So this may be for float, but similar is the concept. Exactly same thing for double. Okay. Fine. Only thing, the size is different. That's it, right? So size is different in case of a double. The number of bits are 64. The exponent bits are 10 in that case. Okay, here it is 10 bits for exponent, 1 bit here, so 11 bits, and rest of the bits out of those 64. And those will go for the significant part. Okay, anyway, so let's proceed further then, right? Coming to the constants for the char type. Yeah. Okay, what are the so for char type, yes, how are the constants written? Yesterday we also did talk a little about Unicode escape. Did I mention about Unicode escape? Backslash U and 4x digit. Okay, so anywhere in Java file you can use that. Right? Now, especially for the char constants, what are the char constants? Okay, how do we specify char constant? They are specified by writing in single quote. And for example, yes, you can. So within single quote, one single character has to be specified. Okay. One single character has to be specified. So you can just say, okay, I do want the capital A. So when you say capital A here, right, we say, okay, this is a numeric type. Char is a numeric type, right? So, for example, if someone says, okay, he is writing char ch equals, and you write k like this, right? So when you do this, in ch, the value for the numeric value for corresponding to a will go. Okay, that's what is going to be stored in ch. Okay, fine. So as far as the numeric types are concerned, right? Uh, did I mention about the hierarchy of the types? No, I think. Let's also look at this one. We have a double as the biggest type, right? Among the numeric type, double is the super type for all of them. Okay? We'll use the term super types of type. Okay? The subtype of double is float, and the subtype for float is the long, and the subtype for long will be the int type. And then the subtypes for int will be, there are two of them. One is the char type and other is the short. Okay, and short has a further subtype called byte. So among the numeric type, this is how the hierarchy is there. Okay, and what this hierarchy indicates is that yes, if there is a byte, fine, it can always be assigned to a short. It can always be assigned to int, long, float, or double. The bigger type, right, the one on the upper side, right, they are, right, they are super types for the ones which are on the smaller, right, the smaller types. So you can't make a reverse assignment. That is, you can't be assigning a double into a float. Okay, fine. You can't be assigning double to anything other than a double. Okay. So once I do something like this, char ch is equal to a, right? And then if I say int x equal to ch, this is valid, right? So what will be the value in x? It will be, what will be the value in x? The numerical value for a. Fine. A is a text, right? It's a piece of text. But when it is a text, yes, we for because it's a text, and we consider it as a also as a text type. But internally, it's just a number. Right? There is a number which is nothing but the, we call it as the code point value for the letter A. Okay, right. If someone writes like this is also valid. Another thing let me explain here is, if you say char ch equals, and if you are writing 65 like this is also valid. Right? What will ch get? Oh, this is same as writing this one. Okay, and both are same. Right. And someone could even be comparing, because x was assigned here, right? And then even after this kind of thing, int x equal to yeah, int x equal to, even here instead of saying ch, someone writes like this, is still valid. Right? So whether you write a or you write 65, a in quotes, or you say 65, it's one and the same. Right? 65 is the decimal value for the character A, and it's the decimal value, and in hex it would be 41. Right? Okay. Yesterday we had put the ASCII character set, right? ASCII character set, you have seen. Okay. Okay, fine. So this is fine. So the hierarchy is fine, and so type hierarchy is one thing. And the now coming back to the character constants, we say we can write it in single quotes, right? Now there are certain characters. So normal yes, normally we would use like this. We would if it's a char type, normally we would use a single quote. Right. So in single quote, let's just see what all can go. So in single quote, if I have to write a backslash, fine, then it has to be written as two backslashes. Fine. Anywhere in a literal, it may be this is a character literal, fine. But you might even be writing a string literal. String literal means you have a sequence of characters. Within quote, when we are writing, it's only a single character. And within double quotes, if we are writing, then it's a string, it's a sequence of characters. Okay, sequence of characters. So even in so whether it is in single quote or it is in double quotes, okay, a backslash. If you want one single character called backslash, you have to write it twice. Backslash is used for escaping. So purpose of backslash is escaping. And for example, we saw yesterday that backslash u has a purpose, right? So backslash it's indicating it's for escaping what is being parsed. While parsing, this is used for escaping. Okay. So like backslash, even we have if I want single quote, I want to specify the character single quote. I have to use in quotes, from single quote, backslash, and then put the single quote, and then the single quote like this. So if there is a backslash, then it is expected that there is something more to indicate what character it is. Okay. So to get your backslash, yes, you'll have to put it twice. Okay. Uh, we also have, okay, in quote, you can use backslash followed by the octal value also. So if you start with a backslash, what is expected? Oh, there are certain characters, backslash, quote, single quote, double quote, okay, all those things are there. And backslash, if you wanted a backslash is taken care. Okay, there are other special values as well. Okay, yeah, backslash, and you can start with a zero and put some octal value. Okay, the octal value for the character can also be given. Okay, start with a zero and backslash zero. Then it is expected that you are given the octal value of a character. Okay, and backslash u anyway. If you are trying to give in hexadecimal, then you can use backslash u and get the hexadecimal value. And the Unicode escape anyway works anywhere, even as part of a literal. Okay. And then there are special characters which are non-printable. And non-printable in the sense, for example, we have the backslash r. Okay. There is also another one called backslash n. Backslash r is known as a carriage return. Backslash n is the line feed. Okay. Backslash t for tab. Fine. So like this is exactly what we have in C language also. We have a list of characters, okay, which are control characters most of the time, which can be specified by using the escape. So backslash is your escape character. Right? Within a literal, right, a backslash represents a escape character. It would then be followed by something, and then the meaning is decided. Okay, so char constants also we know, right? And then, so numeric constants we are aware of now. What is the other kind of constants we can have? What are the other constants? Other data type or Boolean type, right? So for Boolean type, again there are two literals. I think I mentioned already, right? There are two literals, true and false. Okay. They are the two literals, right? They are known as literals. Okay. There's another. Okay, fine. So primitive types. Fine. We understand primitive types now. Okay. Let's look at the reference types. For reference types, yeah, which are the reference types? I think I have listed them. Yeah, which are the reference types? Reference types are, yeah, yeah. Let's see the reference types. Now, okay, one more thing. So reference types. There is one common literal for the reference types, which I'm just mentioning here. So a common literal for all reference types, whatever the various reference types are, there is a common literal called null. Okay, we have a common literal called null. Which are the reference types? We have the reference type are arrays, and array of any type. Right? If there is any type, okay. So, okay, array is how is an array? If there is any type called x, let's assume x is some type, okay. Then you can use square bracket and say I have a opening and closing square bracket. This represents the array type. Array of x. A array is nothing but a sequence of elements of a uniform type. Okay, that type is here. It is, for example, you say x here. Okay? So, example of this, I have just used x here, but the example of this would be that x could be a byte. Okay, x could be any type. Fine, byte is just an example. So, byte array. So, if I want, yes, I can have a elements of type byte, sequence of elements of type byte. Okay, that's a type basically. What is being, this is only a type. Okay. So you can find example of an array is a byte array or int array. Right? Okay. There is a class called string. In Java, we have a class called string. So that's also a data because it's a class. It's a reference data type. So even string array, right? And that's another example. Fine. So array of any type, right? Square bracket after a type name. Right? So, what about this? I have a int array also, right? As an example, I have a int array, right? That is also an example of a array. Int array is example of an array. Okay. So, if I have a int array and we say x can be any type, that means is also an array type. This is also an array type because my type for which the array is being created is an int. That x here could be could be an array as well. So you can have array of an array. Okay. Fine, we call it as a multi-dimensional array. And so multiple dimensions of an array can be there. Okay, let's try to see what how does an array look like. Fine, for arrays, yes. Okay, so let's think about an int array now. And we'll take example for an int array. How do we create an array, right? Because the slight difference from the syntax of C and Java as far as arrays are concerned. Okay. Some similarity is also there, but yes, there is a difference. For example, in case of C language, how do you have an array with 5 elements? Int array with 5 elements. So in C language, okay, you would have used int a and 5, right? I think this is how you do it in C language. Okay, this is not valid for Java. Okay, so this is not applicable to Java. Okay, okay. In Java, yes, a is a variable name. So we could. So there are two possible ways of doing it now. You can say int array. So that's my array type, and say, oh, I have a variable called a. Right? I have a variable called a. Okay. See, now A here is which kind of data type? In which category? Primitive type or reference type? A is a variable of which type? Array type. Arrays are reference types. Okay. What is the difference between a variable of a primitive type and a variable of a reference type? Right? We have in array A like this, and someone says, oh, I have in X. Oh, there is a variable X. Right? Okay. So, what is the difference between the two of them? The difference is like this. If you have a location for X is my location for the variable, there is some location for the variable X, okay, and if I am assigning a value to X, that value is right in the location. Whereas in case of a reference type, A is a variable of a reference type, okay, fine. Then A is not the array. A is not an array. We are saying it is of type array, but basically it is a reference to an object which has an array. Oh, you want the array with. We'll see how to get the array object created. Okay. So a declaration like this in array A is just allocating a reference. It's just about allocating a reference. Okay. There is one variable which is there and it can have a reference to any kind of a object which is of type int array. An object will be of some type. Okay. So arrays are objects. Understand this. Arrays are objects. Okay. How do we create an array object? Okay. So, okay. So one thing was, yes, you could declare. So this is not valid. It's that one is this here, right? This thing here is valid for. Right. So this thing here, this is valid for the. This is not valid for. This is valid for C, but not for Java. And then, as far as Java is concerned, fine. In case of Java, that just to accommodate the convention of C, this is allowed, but this is only declaring a variable. There is no array created yet. Okay, but exactly equivalent of this, I'm just writing a repeat of what is written on top here. So you can. This is also valid in Java without any size because it's not about object. It's about declaring a variable called a to be of type int array. Right? This one looks much better because a is a variable, int array is my type. Okay. Whereas this is just to show similarity with C language. Okay, some kind of a compatibility with the syntax of C language. Right? But this would be more preferable. Right? This is what is going to be more preferable because it's a clear thing. Yes, A is a variable, the type is integer. Okay. And this would also be fine. It's not wrong to have int A and then put the square bracket. Okay. So they can be exchanged like this. Now, as far as creating an object is concerned, yes, allocating array with 5 elements. You want to allocate an array of integer which has got 5 integer elements. Okay. Then, okay. So I'll write the full syntax again. Let's say we have int array A equals. So you can assign also in the same place where you will say new. You want to allocate a new array. And now after new you can write in square bracket, for example, I put 5. So that's the syntax for. So this is nothing but the object with 5 elements. Okay. So this is an object with 5 elements. And when you are saying assignment into a reference type, right, that means start referring to this object. So new in A5 is, you can think, oh, this is what is getting allocated. And when I'm saying A equals, so that means A starts referring here. Okay, A starts referring to the array with 5 elements which were allocated. Okay. And after this, after having done this, the next step, if someone is saying A of 0 equals 35. Okay, if A of 0 equals 35, if someone has put this kind of a statement, what would it do? Oh, this is the reference to A, so A is this object. So whatever A is referring, let's get the first element. Okay, this is where 35 will be put. Okay, and suppose the next step someone says, okay, let me use A equals new in 7. So what do you think happens now? Yeah, what's going to happen? What is this going to do? New in 7. It's going to allocate an object which has got 7 integers. Okay, and A stops referring to this one. You don't refer to this one, but now you start referring here. Whenever you make assignment to a reference type, you are saying equal to, that means it is switching to a different object. And variable of a reference type, you make an assignment, that means shift your reference to a different object. Very clear? Clear about the reference, right? The meaning of reference is now clear, right? Okay, so one thing, what will happen to this object which was allocated? What happens to this? Yeah. Is this usable now? And the array with 5 elements, where the first element was assigned a value of 35, but that is now no longer accessible from anywhere. Fine. So this is like a garbage. This is nothing but it has become a garbage, and this needs to be deallocated. The space which it is occupying has to be made available to other any other object which is being created in Java, right? So within the Java virtual machine, yes, We have something. So when we start, when we execute our application, when we start our main method, right? When Java starts, okay, when the Java virtual machine starts, it's not only executing the main method. Okay, while it is executing the main method, there is also a background processing which is happening, which is looking after if there is any object which is not accessible by anyone. If there is any garbage which has been created, then I need to go and deallocate, make that space available again. Deallocation of objects. Arrays are also objects. Fine. There are other kinds of things which we look at as objects. Except for the primitive types, everything else is objects. Okay. So if there is any such object, we have in Java we have something called a garbage collector. So when you start your Java virtual machine, and we give the Java command, the JVM is starting. At that time, it's not only executing main, it is also executing things which are necessary for garbage collection. Okay. We call that as a garbage collector. So Java virtual machine has a garbage collector. Okay. And the job is to identify garbage and deallocate. Okay. And so clear. Array. Now another thing, for arrays there is another way of, it's not only with the help of new that you have an array, but there's another syntax available where you have array constants. We call it as array literals. So for example, I'll say a equals, and in braces, right, you can have braces and specify the values of the elements. For example, you say 7, 5, 3, 9, 12, something like this. Okay. Fine. See, there's another thing which is available for any array type. And here, A is a variable which is of type array. Okay. Then we can use A dot length to know how many elements are there in the array referred by A. A is a reference. When I say A dot length, okay, tell me the number of elements available in the object which is being referred from A. Okay. Fine, clear? So this is okay. So array, fine. Array initial syntax is how you can, fine. So one is, yes, you can do it like this. Okay, what about this? Just tell me whether this is valid or not. A we know is of type int array. And I put something like this. What do you think? This is valid or not? Yeah, it is expecting int values, right? So is it valid or not? And this would be valid. Because writing in single quote as a char, fine, A is like you are specifying the value 65. And here writing B like this is like you are specifying the value 66. Okay? And so this would still be valid. So char is a numeric type, understand that? Okay. Char is just a numeric type. It has a numeric value and that's how it will be treated. And, if someone has, if someone says, I have got CH1 equals A and I have got CH2 equals B, and then says, oh, let me print what is CH1 multiplied by CH2. Yeah, it will be able to compute this. It will be 65 multiplied by 66. Okay? Fine. So, array initial syntax. Okay? Fine. Like we have array of int. Fine. We understand when we have an array of int, the values are available in the, we have a multiple values available in the object. And so one object with multiple values which are of type int. Okay. Now let's move further and let's have an array of a reference type. Okay. For example, we have a class called string and therefore we can have a string array also. String array. Okay. And someone says let's have a string array names equal to, and here maybe we use the literal and you can write like this. Uh, you have a few names here. Okay, maybe let's keep two names here. Okay. So now what will be names dot length? That's going to be 2. There are two names, two elements in that array. Okay, fine. Names 0 will be James. Names of 1 will be Josh. Fine. And okay, fine. So when I have done this, right? So let's see how the allocation is happening. Okay, it's a string array names. So here is a variable names. This is nothing but a reference. Reference to what? Reference to an array. Okay. What does this array have? It has got two elements. This object has, array object has got two elements. Okay. What's the first element? What's there in the first element? Okay, fine. Let me ask a simple question. We have got string array names, right? We have assigned like this. The type for names is string array. The type for names is string array. What is the type for names of 0? What's the type? Names of 0. The type of the elements is string. Fine. Names of 0 is of type string. It's an array of string elements. So here, if this is the string type, right, then what is it? String is a reference type. Understand? String is a reference type. So this is a reference. The elements of that array are references to a string object. So here you have a reference to a string object which contains the value James. So it's something like this. Okay. And here is a reference to this. Fine. So clear with area of a reference string. Okay, fine. Now area of another reference string. Let's consider area of a. This is area of a string, right? Okay. Here again, you can do a similar thing like names. Here also you could be using something like symbol. Names equals and new, and you could have said string, and in square bracket specify the size. Okay, I want 5 string elements. Right? So when I do like this, when I say new string 5, this is like names is a variable, and then we have an array with 5 elements. And what are these 5 elements? Okay, and names instead of referring here and start referring here. But what are these 5 elements? They are references. But do they have any string? Each of those references, they don't have anything at all. Initially, they would not have anything, no objects being referred from the elements in that array. And their initial value is what we say is null. Okay, so their initialization by default is to null. Same way, when we allocate an array of any numeric type, like we allocated an array of by saying new. If I say new int 5, it has allocated an array with 5 elements, 5 integers in that, and their initial value will be 0. Okay, when we allocate array, right, the elements of an array by using new here. Okay, if you use new and allocate an array, right, then their initial values are going to be, if it's a numeric type, it's going to be 0. If it's a boolean type, it's going to be false. Boolean is true false, it's not a numeric type. And if it's a reference type, it's going to be null. Okay, so initial value for elements of an array. Okay, if they are allocated using the new. Okay, and next step, let's see the next thing. Okay, now we have done array of integer. Okay, so next let's try array of an array type. Okay, we had string array. String was a reference type. If I'm using this, okay, and let's say I use the variable name as a. Okay, again, understand this is equivalent to writing in array a array, okay, or it is also equivalent to saying all three are equivalent and valid. Okay, all three declarations for declaring a variable a of type array of integer, and I call it as array of integer. Okay, fine. It's an array, and it's an array because of this, and the type is integer. Int array is a reference type. Just like we were looking at string type, right? String was again a reference type. Okay. So when someone says, "Oh, how do I allocate an using new?" Let's use new to allocate a two-dimensional. Yes, we call it as two-dimensional. Let's see how it can be done. So if this is the next step, we are saying a equals. Let's create using new. So if I have to allocate, I must be using two square brackets. That two, okay. So it is possible to you have to give at least value of one of them, not one of them, the first one at least. Okay, so you'll say, oh, I want to allocate an array which has got 10 elements and in the first dimension, and then you can, now here it's optional, you can leave it blank or you may specify a size. You can leave it blank also or you may specify a size. Okay, let's first go by specifying the size. So we have said new int 10 5. Right. So when I do it like this, a equals new int 10 5. Okay, a is of type array of integer. Fine. A, the type is array of integer. So what's the type for? What is the type for a of 0? What's the type? This is of type. The elements are of type array. Okay, fine. And if someone says A00, because it's a two dimension, A0 is my array type already. In this array, give me the 0th element. This is of type. Okay, fine. Let's look at the allocation part, how the allocation happens. Okay. So if you have done new int 10 5, okay, this is how you have done. How many, okay, now let me put a question here. Okay, what is a dot length? What should be a dot length? I have said a equals new int 10 5. What should be a dot length? You expect it to be 50. How many elements of type int array? How many integer arrays are there? The elements of that array are int array, right? What are the elements in this array? They are of type int array. How many int arrays are there? There are 10 integer arrays. Okay, there are 10 integer arrays. A dot length is going to be 10. Okay, A0 is an array. A0 dot length is going to be, yeah, what will be A0 dot length? Because A0 is an int array, right? A is array of int array. A0 is an int array. What is A0 dot length? 5. A1 dot length? Another 5. Okay, so look at this, how the allocation is actually happening here. It's like this. You've got reference A referring to an array with how many elements? You allocated 10 elements. Okay, this is index position 0 and this is your index position 9. Okay. Each one of them has a reference to another array where we have got 5 elements. So this is referring to one set of 5 elements, or there's another one, 5 elements. This is referring here. A1 refers here, right? A2 and so on. Everyone, right? Each one of them has its own separate array of size 5. each one is having a separate array of size 5. And yeah, so this is this A refers here. A refers to the array with 10 elements. So A dot length is 10, A0 dot length is 5, A1 dot length is 5, and so on. And now, if someone does like this, someone says, okay, let me have, after this is done, after this new is done, okay, let me have A of 0 equals, because A0 is a, right, it's an array type, right? So A of 0 equals new in 7. So if it does like this, new in 7, what happens? If this is what is done, what would happen? Right. There will be an array with 7 integers. We said new in 7, so there has to be 7 integers which is allocated, and from here you stop referring to this but start referring to this one. This is the A0, right? This one is A0, and that refers to this. And objects, and a variable would only refer to an object, reference variable. Okay, fine. So in Java we have got those primitive types, and we saw those primitive types earlier. Okay, fine. Just a small, one more thing about. So we can say yes, those integers, right? Byte, short, int, long. Those we had those 8 types, right? 8 primitive types in Java, right? So we have those primitive types, but also corresponding to those primitive types, we have got classes. We have got classes corresponding to each of those primitive types. Fine. Let me put the list, and those classes are actually known as reference types, wrapper classes. So we have the type as byte, short, int, long, float, char, and the boolean. Fine, we know these primitive types, but for each of those primitive types, okay, there is what we call as a wrapper class. So there is a wrapper class for each of them. So for byte, yes, there is a class called byte. For short, yes, there is a class called short. For int, there is a class called integer. For long, there is a class called long. For float, yes, we have a class called float. Double, there is a class called double. D will be capital. For char, there is a class called character. And for boolean, there is a class called boolean. Okay. Fine. So if you want to have an object for a primitive type, yes, we have classes where such things can be are available. Okay, one-to-one mapping, right? For every primitive type, there is a wrapper class. Okay. Now, other than this wrapper class, also there is one more small thing which I can mention here. We have a return type called void. It's not a data. It's not for any kind of a data. Right? It's not for any kind of a data. We do have something called void, and corresponding to the return type void, there is also a class called void for which no objects are available. There are no objects for the type void. Okay, but we do have a class called void. Just understand that. There is a class by the name void, and we can't have any objects of this class. Okay, but class exists. Okay. So except I'm not talking about the void type, but the other things. Except for these, if you have any variable of a primitive type, if it is a byte, you can assign it to the corresponding variable of a reference type and vice versa. Okay, that means if you have got an element of type this, it can be assigned to a byte. It's one to one like this. Okay, and these classes, the byte, the short, the integer, the long, the float, and the double, fine. And we understand char is a numeric type, but they have not accommodated these. These up to this point, right? They have a common superclass. These are classes. Okay, all of these are nothing but names of class. Even within class, there is a superclass subclass that hierarchy exists. So all of these byte, short, integer, long, float, and double, fine, these all, fine, they all have a common superclass by the name number. So we have a class called number being a superclass for those numerical wrapper classes. Character has not been accommodated in that. Okay, just keep in mind. Yes, though char is still a numeric type. Okay. Also, one more thing you should understand: we don't have the kind of hierarchy for the primitive types. Fine, whatever is available for the primitive type. Same is not the hierarchy here. You can see we don't have something like saying, oh, double is the double here. Fine. Okay. And the double here, okay, fine. This double here, yes. And this is not a super class for float, and this is not a super class for long. It's not a super class for integer. Fine. And integer is not a super class for the short or even the character. Fine. Their superclass is one called number, and they don't have further subclasses. These classes here, they do not have any further subclasses. Each one is independent. Whereas when we look at the primitive types, they have a hierarchy. The numerical primitive types, they have a hierarchy. So same hierarchy is not being managed for the wrapper class. Just keep that in mind. Okay. So you can't be assigning. You can assign a byte to a primitive byte, right? I said primitive and wrapper. The corresponding assignments can be done to each other. Okay, fine. That has been allowed. Actually, this is known as boxing and unboxing conversion. So there is a conversion from the primitive to a object of type byte. Okay, we call this as a boxing conversion. Like primitive value is put inside an object, so it's a boxing conversion, put into a box kind of thing, right? And if you are converting from a wrapper to the corresponding primitive, we call it as a unboxing conversion. So we have a boxing unboxing conversion which is happening between the primitives and the corresponding wrappers. Okay. Fine. Now, just one point related to the dimensions of an array, and we're looking at array again. So the dimensions of an array. So for the dimensions of an array, yes, we saw we have one dimension, we can have two dimension array of an array, and array two dimension array is also a type, and you can say, oh, like we have an array of that also. Can do that. But there is a limit to how many dimensions you can have. Okay? How many dimensions? Fine. 2 dimension, 3 dimension, 4 dimension. Okay, fine. And you can go on and on with those number of dimensions. Okay, where your dimensions can go up to 255. Okay, so next number of dimensions is going to be 255. So number of dimensions which you can have. So maximum number of dimensions is 255. Okay, so array type, and some introduction to the. So we have the reference type, some introduction here. Okay. Fine. I think what we can also do here is we can say, let's see some one more utility, which I think I have not shown you earlier. There is one utility called JShell. Okay, this is available from Java 9 onwards. Okay, so we have something called JShell. Let me show some things here. Okay. So if we have JShell, in JShell we can say, we can try some of the things which we were looking at earlier. We can say, for example, we want to try out what happens when we have a int array a, and I can say equals new int 5, right? That was something. Yeah. Okay, fine. This one is a interpreter mode, and you can see what you are doing, right? So you can just for quickly trying out some of the concepts. Okay, some of the coding part. Yes, you can just individually try to write that code and see the results there. Okay, so this is one. Okay, so when you allocate like this, or you could have said, okay, now you can see that a dot length. I can just ask a dot length, and it will say, okay, that's fine. Right? And okay, want to go to the two-dimensional array part. A equals, and one way is you can say new. Yeah. Oh, I forgot this part. I'll say new int 10 and 5. Right? If this is what you've done. Okay. So it puts a dot dot dot, but you can see what's happening. So it says yes, it has allocated like this. Okay. If you didn't see something earlier which was like this, you have a two-dimensional array A. Okay, A is already a two-dimensional array as a declaration. I can now say equals new int. I just say 10, but I don't specify the other thing. So what would happen in this case? Yeah. If I write like this, what do you think happens? It will be having how many elements? 10 elements, the way it was earlier. Fine. At the first level, 10 elements, but each of those elements is a null. There's no array of 5 assigned further. Okay. Okay, let's see. So, what does this do? It says, oh, we got these 10 nulls there. Okay. Fine. And then you could be doing something like saying, okay, okay. So we could be doing something like a of 0. Oh, I think it's not showing up. Okay, let me try to have a. Okay. Fine. So we can now say a of 0 equals, and it's an array. I can say new int 7. Okay. Now just say what is a. It shows like this. First one is right. First one has the 7 elements, and then onward it's all null. Okay. See, another way of allocating a two-dimensional array with literal. Now we can use literals here also. We can say int array of array, or okay, a is already of that type. We can say a equals in braces, right? And then because it's a two-dimension, you can start like this. And each one has a different size. We are not giving the same size, and this is also fine. Okay, so I end like this. Yeah. I think yeah. This has to be braces. Yeah. Square brace. Okay. Yeah. See, if I declare, see, one more thing here. When you use this literal thing, okay, braces, okay, fine. If you are assigning to a declared variable, then you will have to mention the type. Okay, fine. Mention the type in the sense you have to use the new. Okay. Otherwise, so, but if you are declaring here itself the type, right, then this is okay. Fine. But later, if I have to do it, let's see how it would have been done. If I'm assigning, okay, then here you have to say new int array like this. Okay. Right. So when assigning to a variable, if you are assigning in the array literal, okay, at a later stage, not at the place of declaration itself. While declaring the type and then in the same line, if you are writing, that's fine. Fine. But otherwise, you will have to specify the type by using new again. And there you will have to say new. See where this where you might like to use uh, array, two-dimensional array, which has different number of columns for each of the rows. Right. First dimension we consider it as rows. So we are saying, oh, we have got 10 rows and each of them has 5 columns. Right. We have 10 rows with 5 columns. When I am saying 10, 5. Right. But when I am leaving it as 10 and I am not specifying, then each one is being assigned a different, right? So the length of each of the rows can be different. That means each row can have different number of columns. Okay. A quick example of that would be something like that. You have got a two-dimensional int array. Let's call it as sales figures. Okay. Equals, and I might go like this. I'll say, okay, monthly sales. Okay. Let's say month-wise sales equals, and then I'll say int 12 for the 12 months. Okay, and second dimension, leave it blank. Oh, we forgot the keyword new. Okay, fine. So it has allocated 12 nulls. Okay, next step, what will be the next step? Okay, you can say month sales of 0, when 0 would be for the first month. Okay, equals new int 31. Fine. So this is your, this is okay. If I look at month sales, month-wise sales, okay, it shows like this. Fine. The first one is 31 elements, and then rest of them are still null, and then you can still be assigning and saying, okay, I want the next one with only 29. Okay, and if you say monthly sales, yes, there's a first one, there's a second one, and rest of the things are still null. Fine, got the idea? Okay. How why a two-dimensional array with different sizes for the different length for each element, right? Okay. Okay. Fine. So this you can populate. So this is like day wise sales figure, and that too month wise, day wise, month wise. Right? For each month, each day, oh, what are the sales figures? And you might have like this. Okay. So yes. Now more thing. How do I iterate over the elements of an array? If I want to iterate over all the elements in an array, yeah. Okay. Maybe I think I'll do it here. Okay. So this is then going to be 30 for the month, which is 3, for 31 for the month, which is 4, 30 for the month, which is, this is June basically, July will be 31, August is again 31, October is going to be 31. Okay, fine. Let's see what's the. Okay. Fine. So it's anyway allocated the array. How do I iterate over all the elements of an array? By using the for loop. Okay. So let's see the for. How do we write a for? Okay. How do we want to use it? Maybe you want to populate with a plus b, something like that. Row number and column number. Let's just populate by that. Okay. So we can write some code like this: for int I, or I'll say row equals 0 semicolon. What's the next thing? Huh? Month-wise sales of I. Month-wise sales dot length, sorry. Okay, month-wise sales dot length, right? Row plus fine. And then within this for loop, we can write another for loop for int column equals 0 and column, sorry, I think made a mistake. Anyway, let's see how to correct this. Can it go back here? Yeah. Okay, so column less than of row dot. Okay, and then here we might write that okay, let's have month-wise sales of row and column equals row plus column. Okay, fine. We are just simply assigning levels. Okay, so it has executed this, and let's see month-wise sales. The idea was to let you know how to iterate over the two-dimensional array. Normally single dimension, fine, we have done that single dimension. Fine. When we use those command line arguments, fine, go up to args.length. So here also go up to, for the first loop, we are saying the outer loop is saying month-wise sales dot length. Okay, go up to that. The first variable, row is the first variable, right? And then for the inner loop, we have to use the, because it's an array type again, right? So you can use the each individual array's length, the length for the array. Okay, clear how to go over the elements of an array. Okay, now tell me what will happen if I write something like this. Now, if I mention this month-wise sales of 2 equals month-wise sales of 0. Yeah, what will happen? What is the effect of this one? Any guess? No. What does this actually do?
Compare.
No, it's not comparison. It's an equal to sign, assignment. Okay, let me show here. So it's like this, right? Or I'll put another example here. Okay. So you have you got an A equals because the concept which I'm trying to ask is not about array with different sizes. That's it. It was like this, right? So this is suppose what you have done, and the next step what you are writing is you're saying a of 2 equals a of 0. What's the effect of this? Let me write more code here. Now let me write iteration. I've done a2 equals a0. Okay. And after doing a2 equals a0, if I am writing the for loop for in I equals 0, I less than a of length, let I plus plus, and then we have the nested loop which is for. Okay, whatever we have done earlier, in fact, I'm just repeating that. Okay, we did it with month by sales for int j equals 0, j has to be less than a of I dot length. Okay, a of I dot length, and then we have j plus plus. And in this loop, we are saying a of ij equals I plus j. Okay, fine. So this is what I've done. So now after this code, if I'm saying let's print the value of, so system out println a of 0 a03. So what do you think is printed? Ij is I plus j. You understand? A of ij is been assigned I plus j. So what should this print? A of 03. Okay. And you can't be ignoring this statement. Yeah. Okay. What is the effect of saying A2 equals A0? They are references. That means from this point onwards, the third element, A2 means the third element, will refer to the array. It's an array. It will refer to the same array which is available from A0. Okay, it will refer to the same array which is referred from A0. Okay, so whether I use A0 of something or A2 of something, they would mean the same place. Fine. A2 equals A0 means A2 and A0 are equivalent things. For the next dimension, so if I say A2 of x or A0 of x, oh, it's the same. It's the same location I'm looking at. Okay, after this one. So now tell me what happens. What will be this? A03. What will it print? Yeah? Not two answers, there's only one answer because after finishing this loop we are printing. Right? In the iteration, it will first use I equals 0, okay, and do an I plus j for all the elements available from AI, A0. Fine, for each A0, yes, it's doing the I plus j. Fine, then I becomes 1. Fine. So whatever is for I1, A of 1, fine, when I is 1, it is referring to A1. Fine, in that row again, all the columns are updated to I plus j. Okay, then it comes to I equals 2. When it is using I equals 2, and it is the same array which is available from A of 0. A of 2 and A of 0 are same. It is updating the same place again with 2 plus what was allocated, what was assigned with 0 plus 1, 0 plus 2, 0 plus 3, 0 plus 4 is now being assigned 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4. Okay, so this will be, though I am saying 0, you should think this is 2. So this will be, the value will be 5. 2 plus 3, 5. Okay. And you could get it or, okay, let me put it. What happens is this. Here is A, and here is a and there are 10 elements, 0 to 9, this is 2. Okay. So initially, this had 5 elements. This has its own set of 5 elements. This also had its own set of 5 elements. And so on. The last one also has its own set of 5 elements. Okay. Right. Now, when A of 0 is set to fine, then we had executed A of 2 equals A of 0, right? Yeah, that means A2, you start referring to this guy, but start referring here. A2 equals A0. This is the meaning. Okay, now let's go through the loop. I equals 0. It puts here 0, 1, 2, 3, and 4. I plus j. I equals 1. It puts here 1, 2, 3, 4, 5. I equals 2. And it goes and updates this guy. And this becomes 2, 3, 4, 5, 6. This is how it is updated. This is how it is updating, and then after this has been updated, then we are looking at it updates all other things, right? But now we are asking what is A0 of 3, and this is A03, which was updated to 5. It was earlier set to 3, But then it was when the I value was 2, it has fine, it has updated the same place. And with this, I think you become more clear with the concept of a reference. Fine, clear now? Even for arrays, how it is working. Right, so any questions now? Yeah. Yeah, yes, any questions? Yeah. Okay. Well, so far, whatever we have done, any questions anywhere? Anything which is not understood, I can repeat if you want. Right. And then, because the next thing which we are going to start, okay, I think I'll take it tomorrow and then we'll start it tomorrow only. Next thing which we have to start is we'll have a look at what are the statements and operators. So we'll look at operators and statements. So first we look at what are the various kinds of operators available for the different primitive types mainly. Of course, a few operators for the reference type. Okay, operators, and then we look at the various kinds of statements. This is just a quick view look at what we already know from C language, but wherever there are some differences or some additional things, then we know for, while, if, and switch case. So those all those statements, that's what we have to look at. But there are some new things or some differences from the way it works in C language. Okay, that's what we will cover. Okay? And of course the operators also is there. So most of the operators you will find, okay, they work similar to C language, but wherever there are differences and there might be a few new operators, and so we'll have a look at that. So operators and statement, that's the next thing. So yeah, tomorrow is Saturday, so we'll be meeting next one Monday. Okay. Fine. Unless you have some more questions now, if you have any questions, yeah. And then once we have looked at this operators and statements, then we'll be beginning with the definition of a class. So what goes in a class definition, that will be after these two things. Okay. What exactly is a class? What kind of things go in a class definition? Okay, so if there are no questions, I think we can continue on Monday.